Our modern world hums with activity. We have built cities that touch the sky. We have created machines that can travel at incredible speeds. But none of this would be possible without energy. And for over a century, the primary source of that energy has been fossil fuels. These ancient remnants of life, buried deep within the earth, have powered our industries, fueled our vehicles, and illuminated our homes. Fossil fuels are more than just energy sources. They are woven into the very fabric of our civilization. However, as we delve deeper into the 21st century, we are beginning to understand that our reliance on these finite resources has come at a cost. The burning of fossil fuels releases harmful greenhouse gases into the atmosphere, contributing to climate change and its myriad consequences. In this exploration, we will journey into the world of fossil fuels. We will uncover their origins, explore their diverse forms, and understand the processes that unlock their energy. Join me as we delve into the depths of coal mines, witness the intricate workings of oil refineries, and trace the path of natural gas from well to pipeline. Along the way, we will confront the environmental challenges posed by our dependence on fossil fuels and consider the possibilities for a more sustainable energy future. Buckle up, fellow travelers, as we embark on this illuminating adventure. Our journey begins with understanding what fossil fuels are and their significance in our lives. Fossil fuels are like chapters in Earth's history book. They tell a story of ancient life, death, and transformation. Formed over millions of years from the remains of plants and animals, these fuels represent a concentrated form of solar energy, captured and stored over eons. When we burn fossil fuels, we are essentially releasing this ancient sunlight, harnessing its power to drive our modern world. There are three main types of fossil fuels: coal, petroleum, also known as crude oil, and natural gas. Each has its own unique properties and uses, but all share a common origin. They are derived from the decomposition of organic matter under immense heat and pressure. Coal, a dark and often dusty rock, is the most abundant fossil fuel. It was formed primarily from the remains of ancient swamp plants that lived and died millions of years ago. Petroleum, a thick, oily liquid, originated from the decomposition of microscopic marine organisms that accumulated on the ocean floor. Natural gas, a colorless and odorless gas, often found alongside petroleum deposits, also formed from ancient marine life. These three fossil fuels have fueled our planet's progress for generations. They have powered industries, driven transportation, and provided warmth to our homes. However, as we move forward, we must also acknowledge the environmental impact of our dependence on these finite resources. Our exploration now takes us back in time to understand the fascinating geological processes that gave birth to these energy giants. Imagine Earth millions of years ago. Dinosaurs roamed the land. Giant ferns and towering trees blanketed the continents. The oceans teemed with life, from microscopic plankton to massive marine reptiles. As these organisms lived and died, their remains settled on the Earth's surface and sank to the bottom of lakes and oceans. Over time, layers of sediment like sand, mud, and rock piled up on top of these organic remains. The weight of these layers created immense pressure, compacting the organic material below. As the layers deepened, the temperature also increased due to the Earth's internal heat. Over millions of years, this combination of heat and pressure transformed the organic matter. The specific type of fossil fuel formed depended on the type of organic matter present, the amount of heat and pressure applied, and the length of time involved. Coal, for example, formed primarily from the remains of plants in swampy environments. The high pressure and heat transformed the plant matter into carbon-rich coal. Petroleum and natural gas, on the other hand, formed from the remains of marine organisms deposited in ancient seas. The formation of fossil fuels is a testament to the immense power of time and geological processes. These fuels represent a stored form of ancient solar energy, captured by long-gone organisms and transformed into concentrated energy sources that we rely on today. However, this process took millions of years, and the rate at which we are consuming these fuels far outpaces the rate at which they can naturally replenish. This underscores the finite nature of fossil fuels and the need for sustainable alternatives. Fossil fuels are not created equal. They come in different forms, each with unique characteristics and applications. Coal, for instance, is categorized into four main types: anthracite, bituminous, subbituminous, and lignite. Anthracite, the hardest type of coal, boasts the highest carbon content and burns with the most heat, making it ideal for industrial processes. Bituminous coal, also high in carbon, is widely used for electricity generation. Subbituminous and lignite coals with lower carbon content are generally used for power generation and industrial purposes. Petroleum too exhibits diversity. It exists in various forms, from the thick viscous bitumen found in oil sands to the lighter, more volatile crude oil extracted from conventional oil wells. This variation in consistency and composition dictates the methods used for extraction and refining, ultimately impacting its suitability for different applications. Natural gas, primarily composed of methane, is the cleanest burning fossil fuel. It is often found alongside oil deposits and is extracted through wells drilled into underground reservoirs. Natural gas is a versatile fuel used for heating, cooking, electricity generation, and even as a feedstock for fertilizers and other products. Understanding the different types of fossil fuels and their properties is crucial for their efficient and responsible utilization. It allows us to optimize their use in various sectors, maximizing their energy output while minimizing environmental impact. Section 5. Coal's hidden treasures, destructive distillation and its applications. Coal, often perceived as a simple black rock, holds within its depths a surprising array of valuable substances. Through a process called destructive distillation, we can unlock these hidden treasures, transforming coal into a diverse range of products that extend far beyond its traditional role as a fuel. Destructive distillation involves heating coal in the absence of air, breaking down its complex organic molecules into simpler compounds. Imagine a giant oven, sealed tight, where coal undergoes a metamorphosis, releasing gases, liquids, and a solid residue. Each of these byproducts has unique properties and applications. Gas is released during this process, primarily hydrogen, methane, and carbon monoxide, can be used as fuels themselves or serve as raw materials in the production of chemicals. The liquid component, known as coal tar, yields a treasure trove of valuable substances including benzene, toluene, and naphthalene, used in the manufacturing of dyes, plastics, explosives, and pharmaceuticals. The remaining solid residue, called coke, is a high-carbon fuel used in various industrial processes such as steel making. Destructive distillation exemplifies how human ingenuity can transform a seemingly simple resource like coal into a diverse array of products that support various industries. It highlights the interconnectedness of different sectors and the importance of resource optimization. Section 6. Black gold, petroleum refining and its significance. Petroleum, often referred to as black gold, is a complex mixture of hydrocarbons, each with a different boiling point. Extracting it from the earth is only the first step in a fascinating journey that transforms this raw material into the fuels and products that power our world. This transformation occurs in sophisticated refineries where crude oil undergoes a series of processes to separate its valuable components. Imagine a vast industrial complex, a symphony of pipes, towers, and vessels where crude oil embarks on a refining odyssey. The first stage, fractional distillation, resembles a giant sorting machine. Crude oil is heated to a high temperature and pumped into a tall distillation tower. As the vaporized oil rises through the tower, it cools and condenses at different levels, separating into fractions based on their boiling points. Lighter fractions, such as gasoline and kerosene, condense at the top of the tower. Heavier fractions like diesel and lubricating oil condense at lower levels. The remaining residue, a thick black substance called bitumen, settles at the bottom. Each fraction then undergoes further processing and treatment to enhance its quality and meet specific requirements. Gasoline, for instance, might be blended with additives to improve its performance and reduce emissions. Diesel fuel might be treated to remove sulfur, reducing its environmental impact. The refining process is a marvel of engineering and chemistry, transforming raw petroleum into a wide range of fuels that power our vehicles, airplanes, and ships. It also yields a surprising array of byproducts, from plastics and fertilizers to cosmetics and pharmaceuticals, highlighting the pervasive influence of petroleum in our daily lives. Section 7. The invisible powerhouse natural gas, formation and applications. Natural gas, often found alongside oil deposits, is a versatile and relatively clean-burning fossil fuel. It formed over millions of years from the decomposition of ancient marine organisms, subjected to immense heat and pressure deep beneath the Earth's surface. Unlike oil, which exists as a liquid, natural gas exists in a gaseous state, trapped within porous rock formations. Imagine vast underground reservoirs like giant sponges, holding this invisible energy source. Natural gas is extracted through wells drilled into these reservoirs, often using the same infrastructure employed for oil extraction. Once extracted, it undergoes processing to remove impurities and prepare it for transportation and use. Natural gas is a versatile fuel with a wide range of applications. It is commonly used for heating homes and businesses, providing a reliable and efficient source of warmth during colder months. In the realm of power generation, natural gas-fired power plants are becoming increasingly prevalent, offering a cleaner alternative to coal-fired plants. Beyond its role as a fuel, natural gas serves as a crucial feedstock in various industrial processes. It is a key ingredient in the production of fertilizers, plastics, and other chemicals. Its versatility and relatively clean-burning nature have positioned natural gas as a bridge fuel, helping to facilitate the transition to a more sustainable energy future. Section 8. Guardians of Fossil Fuels Organizations and Conservation Efforts. The responsible management and conservation of fossil fuels are paramount in our journey toward a sustainable energy future. Recognizing this imperative, organizations like the Petroleum Conservation Research Association, or PCRA, in India, and similar bodies worldwide, play a crucial role in promoting efficient fossil fuel utilization and exploring alternative energy sources. Imagine a network of dedicated individuals, scientists, engineers, and policymakers working tirelessly to maximize the benefits of fossil fuels while minimizing their environmental impact. PCRA, established in 1978, spearheads initiatives to raise awareness about fuel conservation, promote efficient energy use in industries, and encourage the adoption of renewable energy technologies. These organizations conduct research, develop technologies, and implement policies aimed at reducing our reliance on fossil fuels. They play a crucial role in educating the public about the importance of energy conservation and empowering individuals to make informed choices. Through their efforts, these organizations act as guardians of our energy future, striving to balance our current energy needs with the imperative of environmental sustainability. Section 9. Towards a Sustainable Future. Reducing our reliance on fossil fuels. As we look towards the future, it's clear that our dependence on fossil fuels cannot last forever. They are finite resources, and their extraction and consumption have significant environmental consequences. The challenge before us is to transition to a more sustainable energy future, one that relies less on fossil fuels and more on renewable energy sources. This transition will require a multifaceted approach involving technological advancements, policy changes, and individual actions. We must invest in research and development of renewable energy technologies, making them more efficient and affordable. Governments need to implement policies that encourage the adoption of renewable energy, such as carbon taxes and incentives for renewable energy production. But the transition to a more sustainable energy future also requires individual action. We can all play our part by reducing our energy consumption, embracing energy-efficient technologies, and supporting policies that promote renewable energy. The journey away from fossil fuels will be gradual and will require a collective effort. But by embracing innovation, implementing sound policies, and adopting sustainable practices, we can create a brighter and more sustainable energy future for generations to come.